Before we discuss over reinforced and under reinforced concrete beam, first of all, you should know what is a reinforced concrete beam. A reinforced concrete beam is a structural element which are designed to carry both horizontal and vertical load. It is also called reinforced concrete beam because inside the beam we usually provide reinforcements which are called rebars. These rebars, which are provided in the beam, or we can say the steel, they increase the strength of the beam by allowing the beam to cope with tensile stresses and also resist bending. Without the steel reinforcement embedded inside the concrete beam, then the concrete beam will become brittle and they will fail under loading. So based on the tensile strength of the steel that are considered for the analysis and design of beam, we classify them into three sections. We have the under reinforced section, the balance section, and we have the over reinforced section. Let's discuss each one of these. An under reinforced section beam is a type of section where the steel is used for its ultimate tensile strength. When we have under reinforced section, they undergo tensile failure. In this section, the quantity of steel provided is not enough to get compressed in compression area to their highest permissible value. So if there happen to be a failure in the beam, then the steel will fail first, which means a ductile failure. We know that concrete is strong in compression, but it is weak in tension, and steel is very good in tension. Therefore, the steel which is provided at the bottom of the beam will give a warning before it fails. This is what we know as yielding of the steel. So the steel is going to yield before the beam fails. You need to understand that yielding of the steel in under reinforced beam does not mean the beam has failed. When yielding of the steel takes place, there will be excessive deflection and cracks will appear in the beam before it fails. When this happens, this will give at least enough time for the people living inside the building to move out before the beam fails. This failure in under reinforced concrete beam occurs due to the concrete reaching its ultimate failure strain of about 0.0035 before the steel reaches its failure strain, which is about 0.20 to 0.25, which is much more higher than that of concrete. In a balance beam section, the ultimate strength of the concrete and that of the steel are reached at the same time, meaning when the failure occurs, at that same point of time, the concrete and the steel will fail. When this happens, the failure of the beam will become a brittle failure. There will be no warning or sign of failure because the concrete fails in tension, and we know that concrete is very bad resisting tension. Therefore, at this point, before the yielding of the steel occurs, the concrete will fail, and this is very bad. We don't want this to happen. In this over reinforced beam section, the amount of steel in the tension zone is greater than the amount of steel required to make the concrete in the compressive zone to get compressed to their most extreme admissible value. What do we mean by this? The yield strength of the concrete is reached before the ultimate strength of the steel. Because of this, in over reinforced beam section, they undergo compressive failure. This will lead to a brittle failure when we have the members failing in compression. Therefore, no warning or sign of failure is going to occur, and we know that concrete is very weak in tension but they are good in compression. And this type of section is not advised to be used for beams because not only will it have a brittle failure, it will also increase the cost of the construction due to the higher percentage of reinforcement which is placed in the beam. Therefore, if we compare these three beam sections, it is always advisable to go with under reinforced beam sections because not only is it cheaper to construct, it is also safer compared to other beam sections. And this is because of its ductile failure, which give warning to the people inside the building enough time to evacuate before the collapse, and therefore this is going to reduce the intensity of the hazard. If you find this video educative and entertaining, you can like the video and comment. Also, share this video on social media for a better reach to other civil engineering students, civil engineers, and structural engineers. Leave your opinion in the comment section below, and don't forget to hit the red subscribe button to subscribe to the channel in no tutorial for more construction videos like this. With that being said, you all have a good and a wonderful day. God bless you. Bye bye.